Alright, so part 2, Electric Boogaloo. Let's get started. Limits. So a lot of you have been asking me just to review limits real quick, and honestly, yeah, no problem. Because with limits, you really got to realize there's only 4 possible scenarios. Either you have the limit as x approaches a number of your function, and that's equal to a number. You either have the limit as x approaches a number of your function, and you get infinity. You have the limit as x approaches infinity of your function, and you get a number. Or you have the limit as x approaches infinity of your function, and you get infinity. Those are literally the only 4 options that we can get for a defined limit. Okay, so let's draw them, because it kind of has to make sense to us. So option A. Boom, boom. Our number can be positive, negative, who cares? So let's say this is our number. And let's say we have some continuous function. It doesn't have to be continuous, but let's say it is. So as your x values from the left side approach this number, maybe it's 5, who knows? And as your x values from the right approach this number, your y values are approaching another number. That might be 10, who knows? It's just what it is. That is option A, and that's the most straightforward limit. All right, and for B, what's going on is this. If our x values are approaching a number, and it goes to infinity, this one gets a little more complicated. Let's say our number is 5. That means, as your numbers, as you get closer and closer to 5, as your x values get closer and closer to 5, your y values never cross 5. That means there's an asymptote going on. See that? And again, as you get closer and closer, you never pass this. This line. Your y values just explode. All right. So C and D are a little bit more tricky because infinity is not a number. Going toward infinity is more of a pattern. Think of it that way. Because saying as x goes toward infinity, that's saying as your x values get to the right as possible. Yeah, I can't talk today, can I? You're approaching a number. So let's say our y value is 10. That means that you're going as far right as you can, but all your numbers don't cross this 10 line, aka a horizontal asymptote. So kind of what's going on here, but it flipped over. Here, our x values got closer and closer to 5, but our y values exploded. Here, our x values are exploding, but our y values are kind of like saying, we like 10, we don't really want to move from here. So that's what's going on. They're getting closer and closer and closer to 10, but they're never crossing that line. And I saved the best for last. Part D is you went as far right as possible, your x values exploded, and your y values also exploded. So that's literally it. It just keeps on going. A good example for this one is the limit as x approaches 3 of x, because that's just 3. Good one for this one is the limit as x approaches 0 of 1 over x. From the right, and I'll explain that in a little bit, because that's infinity. And then a good example for this one is the limit as x approaches infinity of, again, 1 over x, because that's 0. And for this one, it's the limit as x approaches infinity, we can do of x, because that's still infinity. All right, so this is your basic rundown of how a limit operates. So again, these guys can be positive or negative infinity. And then right now, I'm going to review real quick the right limit, the left limit, and what it means for a limit to be a whole limit. But yeah, these are your limits. These are 4 options if it does exist. If it doesn't exist, I'm about to run through that too. But if it does exist, these are your 4 options. All right, so if a limit doesn't exist, let's do that one real quick. Let's work with this. It's the limit as x approaches 0 of 1 over x. So hopefully y'all know how to draw that, but just in case, this is what 1 over x looks like. Let's look at the right side. So the limit as x approaches 0 from the right of our function, well, if we look at it, we can see that our values are going toward positive infinity. And let's look at the left side. The limit as x approaches 0 from the left of 1 over x, well, y values are going toward negative infinity. And remember, for a limit to exist, we need the limit as x approaches that number from the right to be equal to the limit as x approaches that number from the left. This has to be true for the overall to exist. Unfortunately, that's not what's going on. So this limit does not, that's a m, does not exist. And that's all you need to do.